Hi there, welcome to your first lesson on volume. Well, not this kind of volume. We're going to be talking about volume in geometry, or the measure of space. All right, when we think about volume, we often think of the amount of substance or the space inside of a container, let's say. So this is a good visual for volume, right? Volume. How much space is there inside a particular three-dimensional shape? This video will address a lot of vocabulary surrounding volume, and it will finish with the idea of volumes of prisms and cylinders. So let's get right into it, because there is a lot of vocabulary around this topic, and that's why this is video 1 of 2. Okay, so first of all, when we think about 3D solids or 3D shapes, we can begin thinking in 2 dimensions. So here are what are called nets. Nets are 2-dimensional diagrams that represent a 3D shape when folded. For example, here's a net, and when folded, it creates this 3D solid. And here's another net in blue, and when folded, it creates this 3D solid. So which of these nets here, if you look at them, could you fold and create a cube? All right, I hope that went all right. Sometimes it's tough to visualize, but that's a big part of working with volume and 3D solids, is being able to visualize things in 3 dimensions. Okay, so now let's look at these. Here's some more nets, all these net diagrams here, and we're trying to match these to these solids. This might be a little easier than the last exercise. I think it might be a little more clear how these fold into these, but let's see if you can match them. Okay, so now that we've looked at nets and 3D solids, let's jump right into what is a polyhedron. To give you a hint, this man here is in a polygamous relationship. Maybe you've heard that word. So what do you think the word poly means? And now let's move on to hedron. This is a mythical Greek monster called a hydra. The name hydra comes from the word hedron. What do you think hedron means? So let's put it together now. Polyhedron, made up of poly, which means many, and hedron, which actually means face. So many faces. Polyhedron means many faces. So geometrically, a polyhedron is a solid, a 3D shape with many faces. It has to have 4 or more faces, where each face is a polygon. Okay, so imagine a shape, many faces, and each one is a polygon. Polygons, by the way, are shapes that have angles and vertices, okay? All right, so let's look at this here. Shapes with 3 dimensions, in other words, length, width, and height, are called solids. A polyhedron, we're going to recap again here, is a solid composed of polygonal faces, we just said that connect along line segments called edges. You can see edges here. And let's see, where am I? Okay, edges meet at a point called a vertex. And plural for vertex is vertices. So this is a polyhedron. You can see there are many faces, and each of the faces of this 3D solid is a polygon, or a shape that has angles and vertices. So that is what a polyhedron is. So maybe now you're thinking, okay, if a polyhedron must have polygonal faces, what would be an example of a very common 3D shape which is not a polyhedron? And we'll look at that soon. So that's what we're going to look at here as well. Here we have polyhedrons. Here we have curved solids. These are not polyhedrons. So when I asked you a moment ago to think of common 3D shapes that are not polyhedrons, well, here are 3 very common ones. So let's recap. Polyhedrons must have faces that are polygons, and polygons are shapes that have angles and vertices. Here, all of these, some of them do have multiple faces. For example, the cylinder has a top and a bottom, and then kind of another third face that wraps around it. But all those faces are not polygons. For example, a circle is not a polygon. It has no angles. It has no vertices. So these are not polyhedrons. Now, polyhedrons can be divided into 2 main types. One type are called prisms, and these are polyhedrons that have 2 bases. What that means is there's 2 identical faces that are parallel to each other. For example, here we can say the top and bottom are the bases. They're parallel, and that is a prism. Think of a prism as basically a 2D shape just growing from the ground. So imagine we started with this square on the bottom, and then that square grew up from the ground. It is creating this prism, and on top you end up with the same shape. A cube also is a prism. This one is also a prism. Now this one I want you to be careful. It doesn't grow from the bottom, which looks like a rectangle or square. That's not the base. Imagine this triangular prism having been standing up and now it fell over. Okay, it was standing up on this face, which is this triangle we see in the front here. Imagine that's one of the bases. And then imagine that triangle's on the ground and it grows upwards from that triangle and it creates this 3D shape. And then again, we end up with a triangle in the back. So really, the front and the back are the bases here. They are the two congruent or identical faces that are parallel from each other. Okay, look at the bottom. Now we have prisms, and other polyhedrons are called pyramids. These only have one base. And you can see here, these have one base and then like a single vertex on top. They are different than the polyhedrons, than the prisms. Okay, let me jump over to curved solids. So sphere, cone, cylinder, all curved solids, not polyhedrons. Let's talk about some more things here. So more specifically defined, a prism is a polyhedron with two congruent parallel polygon bases. Let's take a look. So here's the ones we just saw, and you can see them now more clearly. See, two bases. They are congruent, they are parallel. Every one of these has two bases, top and bottom, and it grows between them. That's called a prism. Okay, the bases are parallel and congruent, and prisms therefore are named by their base. For example, this is a triangular prism. This one is a rectangular prism. This base here, well, we're going to say that's a square, even though it kind of looks like a rectangle. Let's say it's a square prism. And this next one, what shape is that? Six-sided shape. That's, not six, that was five-sided. Pentagonal prism. And this one is six-sided. What's that? Hexagonal prism. Okay, those are prisms. Now, the remaining faces are called the lateral faces. So we just said there's the bases, but every prism also has some lateral faces. The ones that wrap around it, they're called the lateral faces. Now, this one has three lateral faces. This next one, four lateral. This next one, four lateral. This one, five lateral. And finally, six lateral faces. Notice that the number of lateral faces depends on what shape the base is. See, if the base is a triangle, there will be three lateral faces. If the base is this rectangle, there will be four lateral faces, and so on and so on. Okay, the height of a prism is the distance between the bases. So you have a base here, the height is considered that connecting line at 90 degrees from base to base. And you can see it everywhere here. Now, a cylinder is kind of like a prism, but it's not a polyhedron, right? So a cylinder is a solid with two congruent parallel circular bases. Again, not a polyhedron. Why? Because the surfaces or faces are not polygons. So, but it is like a prism in that it has two identical bases parallel from each other. Okay, so now let's move into volume. First, when we begin talking about shapes, we often talk about the perimeter. The perimeter is made up of lengths and widths and so on. Those are one-dimensional measures, measures of length in one direction. Area then is a two-dimensional measure. We now say, what is the area or the surface covered in a 2D shape? Volume becomes a three-dimensional measure where you have three dimensions, a length, a width, and a height. Okay, if each net here was folded into a box without a lid, then how many cubes would fit inside? So this question is about a volume. Imagine you folded these little flaps up, and now we're asking how many cubes, like of this size, would fit inside here? If you were putting cubes in there and stacking them in there, how many would fit here? Okay, let's try this one. In shape B, if you folded these flaps up and had this empty box, how many cubes would fit in here to fill that entire volume, the whole space inside there? And finally C, try the same thing. So I hope you're visualizing these coming up, and for example here I can see the bottom of this shape would be 3 by 3, which is 9 cubes, but then when you fold these up there's 3 layers of 9, so that would be 27 cubes here, for example. That is the volume. The volume is the number of cubes. See, the volume is the measure of the amount of space contained in a solid, but we can say it is also the number of cubic units a solid contains. So in other words, how many cubes, if you said we're measuring this thing in centimeters, and you say what's the volume, you're basically trying to find how many 1 centimeter by 1 centimeter by 1 centimeter cubes could fit inside here to make the volume. Let's see if my link works here. Something's happening. All right, let's see. Okay, so here's that idea of volume. I'm going to drag this. Oh, first of all, you see this is 5 by 5 by 5. So the volume is made up of 125 cubes. I can drag this and make it smaller. If I made it a 3 by 3 by 3, then you have a layer of 9 times 3, exactly what we just saw, 27 cubes. That's the volume. So that's why when you say volume, we say 27, for example, centimeters cubed, because it's the number of cubes that fit inside a shape. All right, that's volume. Let's keep going. Okay, so volume, another way to look at volume is saying, hey, if I know the base area of something, and then I stack up layers of that, that's the volume. All right, so for example, this single layer here has a certain area, and then we say, oh, I'm going to make a 3D shape out of that. I'm going to stack up these layers. Well, the volume will just be the base area. So let's pretend this base area was 10. Let's just say that area was 10. And then you stack up one layer. Okay, the volume's 10. 2 layers of that, the volume is 20. 3 layers of that, the volume is 30, and so on. So volume is just the idea of stacking bases and making a 3D shape. Let's see if this link works. Okay, so here's that kind of look at volume, right? We have this net. It can be folded up into a 3D shape. We can add single cubes. We can see we fill the bottom layer with, how many cubes is that? 4 by 5 or something, and then we can fill it up in layers. So volume, again, is just the idea of filling a shape with cubes. How many cubes fit inside it? That's the volume. Okay, so let's keep going from there. So volume of a prism. Volume of a prism is then found by, oh, check this out, stacking bases, right? You find the area of the base and then you just stack them up. That's the volume. So if you can find the base area and multiply by the height, because the height represents how many layers you have, then you will find the volume. So volume is base area times height. Big B represents area of the whole base times the height of the prism. All right, here we have a triangular prism. Same idea. We find the area of the base and we stack up those layers of the same base from base to base, right? The top and bottom are those two congruent bases. We stack them up and the height is how many layers we have. So the volume is base area times height. Find the area of that triangle times the height. There's our volume. Okay, volume of a cylinder is the same thing. A cylinder is not a polyhedron, but we can find the volume the same way. The base of a cylinder is a circle, and a circle has an area pi r squared. And then we can just stack up layers. How many layers of those circular bases do we have until we get the full volume? So our volume is the same thing. It's like stacking pancakes. So volume of a cylinder, here it is. You're just stacking all those circular bases until you fill the whole shape. So volume is base area, which is a circle, times the height. Okay, volume, base area times height. And in our case, a cylinder, the base area is pi r squared because it's a circle. So that's the volume of a cylinder. Again, never forget, stacking bases. Okay, which cylinder has a greater volume? What do you think? Well, both of those actually have the same height and the same base area. It's kind of deceiving. This one looks like it would have a bigger volume, but it doesn't, because these have the same height and the same base, so the volume will be identical. Okay, here's 3 problems to finish with. Here's a cylinder. It has a radius of 2 and a height of 7.5. Find the volume. Pretty easy. Think of stacking bases, so find the area of the base times the height, stack them up. Let's find the volume. Okay, check your work. Volume, base area times height, pi r squared times height. Put in the values we have. There is our volume in centimeters cubed, because remember, we could fill this with a bunch of 1 by 1 by 1 centimeter cubes, and that means 94.2 of those cubes would fill that shape. Try one more. How about this one? Okay, so here we have a triangular base. Oh, we need the area of that triangular base. We learned a formula to do that. The formula is area of a triangle, and we learned to do it with angles, right? So the area of a triangle can be found by this formula. Remember that one? Half times one side times another side times sine of the side in between. That formula, we learned it. That finds us the area of the triangle. Put it into this formula here and multiply by the height, because you're going to stack those triangles and you have the volume, which is this. Hope you figured that out. Hope that makes sense. Let's try one last problem. Here we have this lake. It's named the kidney because it looks like a kidney shape. Its area is this, and the average depth is 28 meters. What's the volume? Well, think of this one like this, right? There's the depth. You have 2 bases across from each other. All you need is the area of this times the height. Let's check. There's our answer. Great job.